The last section in this chapter deals with multiple angles and product to sum formulas. And this section is going to deal with 2 thetas, 3 thetas, 4 thetas that are inside a sine, cosine, tangent. Or if I've got things that are being multiplied, like sine of x, cosine of x, how can I break that down into addition? Or if I've got things that are being added, how can I make them into things that are multiplication? So we're going to be studying 4 types of equations and formulas here in this section. In this section, you do not need to memorize these formulas. It's strictly going to be applying and knowing how to substitute in when you see the type of formula you need. So first of all, there are 4 other categories that we're going to be looking at. The first one is double angle formulas or triple or quadruple angles, just multiple angles. The second one, we're actually not going to do power reducing formulas, so we can cross that off for now. The second is going to be the half angle formulas. The third is going to be product to sum. And the fourth one's actually going to be the other direction, sum to product. So these are all going to be simplification techniques. Once again, you do not need to memorize these. So let's start with double angle formulas. Double angle formulas are when you have a 2 in front of your variable inside the trig function. So here, the sign of 2u, or the sign of 2x. Remember from what we talked about in section 5.3, those multiple angles are going to increase the number of solutions. Since we're talking about double angle formulas, we're going to double the number of solutions. So normally, if you expected 1, you're going to get 2. If you expected 2, you're going to get 4. And here are the 5 main double angle formulas. Sine of 2u is 2 sine of u, cosine of u. Cosine of 2u has 3 different ways you can write it. And then finally, the tangent of 2u is taking the sine of 2u and dividing it by the cosine of 2u. Now, a couple things I want to point out right here. Notice with your cosine of 2u, it looks very similar to your Pythagorean identity. The 1 is equal to sine squared plus cosine squared. Here we have cosine squared minus sine squared is equal to cosine 2u. So just be aware that that is different than your Pythagorean identity. In case you're wondering where these come from, let's just create the sine of 2u really quick. If we think back to our previous section, so for the sine of, I'm going to put 2x. 2x I can write as the sine of x plus x. Break the 2x down to x plus x. And then I can apply the 5.4 identity, sine of a plus b. And you know the sine of a plus b when we break it down is the sine of a cosine of b plus the sine of b cosine of a. But we said right here it's x plus x. So the first part is a, the second part is b. So really all these are x. So the sine of x, cosine of x, plus sine of x, cosine of x means I get 2 sine of x's, cosine of x's, which is what I've got right there. So you can do something very similar for each one of those trig identities to come up with sine and cosine, and then you would divide the result of sine divided by cosine to get tangent. So let's solve a couple of these. The first one, sine of 2x minus cosine of x equals 0 on the interval from 0 to 2 pi. The first thing I should notice right here is the fact that I've got a sine of 2x. As soon as I see that I've got a double angle identity, I want to do a direct substitution. Just like when you had something like cosine of pi over 2 minus x, you knew that was a cofunction and you plugged in sine right off the bat. As soon as you see a double angle like this, you want to substitute straight in. So we know the sine of 2x is the same thing as 2 sine of x cosine of x. Minus the cosine of x is equal to 0. And now I can solve this equation like I normally would. I've got two terms right here. Each of them contain a cosine. So I'm going to factor out a cosine of x. And then I've got 2 sine of x minus 1 is equal to 0. Two quantities being multiplied together equaling 0. We'll set each one equal to 0. The cosine of x is equal to 0. And 2 sine of x minus 1 is equal to 0. Here for my cosine of x is equal to 0, we'll take the cosine inverse to both sides. So x is equal to the cosine inverse of 0. And there's two values from 0 to 2 pi where we get a cosine being 0. And that's at pi over 2 and 3 pi over 2. Right on the y-axis on our unit circle. Second piece over here, we need to solve for x. So we'll add 1 to both sides and divide by 2. So I get the sine of x is equal to 1/2. We'll then take the sine inverse to both sides. Sine and sine inverse cancel. X is equal to the sine inverse of 1/2. And the two values that give us a sine of positive 1/2 in the first and second quadrant end up being pi over 6 and 5 pi over 6. And if I wanted to, I could check those answers by plugging in each of these in for x into my original equation. The second situation is I want to find the sine of 2x, cosine of 2x, and tangent of 2x given some variables. So here I'm giving you the sine of x is equal to 12/13, and pi over 2 is less than x, which is less than pi. Here's the piece you're given. Here's your constraint. Same thing as you did back in chapter 4. We're going to create a reference triangle to represent this value, find all the pieces that we need, and then we'll simplify. So here, this pi over 2 is less than x, which is less than pi, is just saying we're in the second quadrant. So I'm going to draw my reference triangle in the second quadrant. Sine of x equals 12/13. Sine, we know, is the opposite over the hypotenuse. So the opposite is 12, the hypotenuse is 13. And this would be a 5, 12, 13 triangle, so my adjacent would be -5. So I know my sine of x is equal to 12/13. That's what's given to me. Cosine of x is equal to -5/13. And finally, the tangent of x is -12/5. That's fine and dandy, but I really haven't answered the question yet. I want to find the sine of 2x, cosine of 2x, and tangent of 2x. So now that I've found all these x's, the sine of x, cosine of x, and tangent of x, I can go to my equations that I have up here and substitute in. So we know the sine of 2x is 2 times the sine of x, cosine of x. And I found sine of x and cosine of x down here. So the sine of 2x is 2. Sine of x we have is 12/13. Cosine of x we have is -5/13. And to simplify that, we'll multiply across. So the sine of 2x is -120/169. We'll do the same thing for cosine. Cosine of 2x, and we've got 3 different formulas we can use right there. I'm just going to choose to use the first one. Cosine squared of x minus sine squared of x. Any one of the 3 would work. So cosine, we know, is -5/13. So -5/13 squared minus sine squared, which is 12/13 squared. So 25/169. minus 144 over 169 is negative 119 over 169. So my cosine of 2x is equal to negative 119 over 169. And then finally, tangent. I've got a formula for tangent, but I also know that the tangent of 2x is going to be the same as the sine of 2x over the cosine of 2x. The sine of 2x I know is negative 120 over 169. The cosine of 2x is negative 119 over 169. My 169's cancel, and I'm left with a positive 120 over 119 for the tangent of 2x.